All right, hello everyone. I hope you all enjoyed that. I just wanted to do a really quick, like 30-minute or so introduction to databases before our sponsor Firebase comes and talks about their product. So for those of you guys who have done a little bit of web programming, this is hopefully you'll get a little bit more insight into databases from this. For those of you who haven't done any web programming, hopefully you'll get a general idea for why we use databases, what they can do, and sort of see how they can fit in your app. I'm not going to show too much sort of framework-specific code today. That's for Firebase, and then that's for next week. But just sort of like an overall, why do we have this, nice hand-wavy talks today? And unfortunately, I can't give away more legal secrets, otherwise I would. Just kidding. That's all. Anyways. Victor, what's this broken again? There we go. Cool. So, as I said, just a very gentle introduction to databases. So, what is fundamentally a database? Well, this is what Google tells me, right? A structured set of data held in a computer, accessible in various ways. And this is sort of true. It doesn't really tell us what exactly a database does. It doesn't really tell us how it does it. And it's even a little bit inaccurate in some ways. Like databases today don't necessarily have to store data in any sort of structured way. You might have heard about the new hipster NoSQL frameworks and Django's and the Mongos and all of that. But at its core, a database is just really some service that we implement and that we can call upon to store and retrieve and manipulate our data. So, why databases? I built a reasonably functional application yesterday, 2 days ago, without using one. And here's some code that you might find to be a little bit familiar. And at the top line there, you see it says fake database. That's basically just this variable that I created on the server, and I started storing a bunch of things to it. And as you can see in my route here, I'm basically reading from it. So, what are some of the problems that you might encounter if you try to write your entire web application like this? This is again where I throw things at you, or when you answer questions, and then I throw things at you. I know some people really like typing, but don't type. So yeah, why, if I'm building a website for reals, why should I not write my code like this? Yeah?
You set your server, your database.
Right. Alright, I have no idea how these things work. Oh, that's not bad. Yeah?
It might get hard to search through your data once you have like more inputs and more data inputs.
Right, it might get hard to... Alright, these things don't grow very well. Yeah, let me try again. No food in 10250, guys. Yeah, so it might become really hard to actually search through this thing, right? If you can imagine, as I'm adding more and more images, in this case, if I want to search through this, there's like, especially if I'm implementing this as a JavaScript object, like find me the image corresponding to Facebook.com, I might have to go through the entire object, right? So, okay. If I crash the server, if I restart the server, our data's gone. They're like, okay, well I still don't want to use a database. I want to do everything myself. So, what if we write to files instead? If when I create something, I'm going to write a URL to a file. And in order to get a URL, maybe I'll like count the number of lines in the file and then pull that URL up. What are some of the problems that we might encounter if we write to files? Yeah.
Reading from memory is much slower than reading from RAM. Like reading from your hard disk.
Reading from disk. There we go. Yeah. Reading from disk is slow. There we go. Nice. Yeah.
The file can be corrupted if you don't write it correctly, if something happens in the middle of writing it.
If something happens in the middle of writing it, exactly. And if we want to just write one thing to a file, our operating systems give us reasonably good sort of guarantees for what will happen. But what if we want to write like 10 different things though? Yeah, I saw a hand somewhere over here. Yeah. One thing in a file, you have to load most of a file. If your file is really, really big, you don't necessarily have to load the whole file. But you still have to load some amount of information that's more than what exactly you want. Yeah. Back there first.
Is it possible to write this simultaneously? What happens if two users want to write a file at the same time?
Right. It's very difficult to write for two users to write to a file simultaneously, right? And for most of your applications, when you're coding and you're debugging, you're the only one using it, and so a lot of things might seem fine. But imagine a site like, Reddit or Facebook or Twitter, where millions of requests are probably being simultaneously processed on the server at any given time. If all of these requests are trying to line up for access to the same file, you can imagine how everything might be really slow. And as Victor pointed out earlier today, slow sites cause no one to use them. So, that's not good. Any other ideas? I think that's pretty good. That's a pretty good set of problems. So yeah, at its core, it's just, files, ultimately everything's stored on disk somehow, but files are a really cumbersome way for us to actually deal with these things that we want to store. And what you'll find is that if you start off with the system with just a bunch of files and you start implementing all of these things, I want to implement concurrent access, I want to implement being able to search through it efficiently and only loading what I want, you end up taking this really simple idea of being able to write to and read from a file, and you end up building a bunch of layers on top of it, and basically you end up with a database. And so just as a very concrete example of this idea of simultaneous connections and things maybe being corrupted in the middle of an operation, let's consider a very simple thing I want to do. Right? I want to pay Victor $50 for Victor to take some team out to legal secrets. So how might I do that? If you were writing the code to allow Charles to pay Victor $50, how might you write it? And don't think in terms of databases. Just say, okay, I'm writing my Python file, and I have a Charles, and I have a Victor, and I want Charles to pay Victor. Yeah.
Do you have $50 in your account?
Yes. let's assume I have infinite amounts of money. I think I have an answer. Yeah.
Charge $50 from Charles at $50 to Victor.
Exactly. So I might do something like that. Or I might be nice and give Victor the money first, and then take the money out of my account. Right? And both of these solutions really ultimately have the same problem, which is, what happens if I crash right after the first line of each? Right? In the first case, $50 is lost from our system. In the second case, $50 magically appears in Victor's account, and I'm not held responsible for it. Or what if simultaneously, when I pay Victor, I'm like, hey, Victor, I paid you, and it's executing one of these two lines, and then Victor wants to pay Jeffrey for actually taking someone out for legal secrets. Right? You can see here how when we start getting things happening, a lot of things happening together, and a lot of things that really try to affect the same things, like a lot of requests, a lot of actions that affect the same couple of objects, that we start getting these really weird edge cases. And these are sort of edge cases because you're like, okay, well, when I'm building my application, I'll never be able to do this. But these edge cases aren't really edge cases when a million people are accessing your site at the same time. Right. So that was just a really long way to say that databases solve a lot of really hard problems for us. Right. Databases solve the problem of reliability. Right. If your server crashes, you can mostly assume that the stuff that you put to a database is safe. Right. Databases support replicating data across multiple servers. So if you have a server go down, or even an entire data center go down, you'll probably still have your data. Databases help us with performance because we don't have a single machine now that's dedicated to both serving the requests that are coming in from browsers, as well as serving the data that those requests need. Right? We could, if you take any databases class, you'll know that there are just giant lists of optimizations that you can do. Like these used to be these things like SQL engineers, where they would just stare at these queries and make them faster. And also, obviously, handling concurrency, being able to find ways, exploit tricks, so that we can have multiple people maybe reading the same object or writing to the same document at the same time. Right? We talked a little bit about consistency in the example of me paying Victor. Right? How do we make sure that, at any given point in the system is in some sort of consistent state, or that we'll never be able to find the system in any inconsistent state, for example. And multi-step transactions. I'm not going to go too much into detail about them, but for those of you in 6.3s, you'll get to know them very well at some point when you take O33. So you might have heard of these two things, SQL and NoSQL. And NoSQL is actually literally not SQL, but then the SQL community got really bitter. It's like, why would you name something that's literally not us? So then they decided to name it not only SQL instead of just not SQL. But anyways, it's SQL and it's not SQL. It's really what it is. And there are two very different approaches to databases that in a lot of ways accomplish the same end goal, but they do it in two very different ways. And for the rest of this lecture, very briefly, I'll just show you guys the two, sort of like the differences between them, and maybe why you might want to use each one. All right. So when Xander talked about Ruby on Rails yesterday, that was yesterday, right? Yeah. We had this idea of the models, and you might, if you ever build your own Ruby on Rails application, you're using it and you look at the console, you might see a bunch of database queries, and those are SQL. So SQL is the default for Ruby on Rails. NoSQL is generally what's preferred for our more JavaScript-y frameworks like Node and Express and all of those. So, SQL. Who's used SQL here, by the way, just by raising hand? All right, cool. So, so a SQL database, we have a server somewhere, and multiple databases. You might have a database for your entire application. You might have a database for one significant chunk or subdomain of your application. And the most important thing about SQL, so SQL stands for structured query language, and the key word here is structured. Right? The main thing you need to know about SQL is that it enforces a very tight structure on the way that you store your data. And the way it enforces it is in tables. So you can really think about it, like when you might be organizing something for, like, say, a student group, you fire open Google Spreadsheets, and you have a list of names, maybe, a list of, maybe years, a list of emails, and so on. So here I have a very simple SQL database. 3 users, and you notice that each one of them has an ID. That's the other thing that SQL is all about. It's all about keeping IDs as references to things. And so you might have a table of users and you have a table of content. Let's say we're making a blog application. And with any SQL database, you need to declare to it how the data is going to be structured. And the database will enforce that everything you put into these tables conforms to the structure that you declared. So I said, okay, my users table has 2 things in it, an ID and a username. The ID will be an integer, and it'll be what I call the primary key, which is basically what the database orders these things by, like 1, 2, 3, and so on. And the username is going to be something that is a variable number of characters up to 40. And similarly for the posts, except I'm going to allow for more text to be in the content. And so you'll never get a situation in SQL where you load a table and maybe there will be a string in the ID field. It just will never happen. The database will not allow you to insert that as a record. Okay. Now, you might ask the question, cool, this is really cool. I have a bunch of users and I have a bunch of posts. Well, that's not very interesting. I can probably display them and that's about it. What web apps are really fundamentally about is talking about the relations between objects, right? If I go on Facebook, who are my friends? What things have I posted? what things have my friends posted? What things have I liked? Where are my comments and who has liked them? And all of that, right? And you can imagine it would be really, really cumbersome to have to replicate all this information. So it would be really sad if we had to, every time we created a wall post, we had to put all of our users' information in that wall post object, right? Like, that would be really sad. Like, we would use a lot of space and literally store nothing. So SQL has this idea called basically relations. So let's say I wanted to explain, I wanted to explain how these posts were related to the users. Who created each one of these? Well, then I'll basically just create this third column right here. And all that thing will consist of is an ID, which points over to my users column. Right? So you can think of these as maybe pointers or references in Java or C. But basically what you're doing here is it's just a really lightweight way to say, instead of actually copying all of this information over here, we're just going to say, if you want the user information, go look into this table. Any questions so far? Cool. So I want to show you a couple of examples of queries. Kind of create a table, and you see here when we create a table, we declare the schema. Integer, characters, enforcing uniqueness properties. That's another really cool thing about databases. They enforce properties that aren't necessarily even obvious. We can insert, we can select, we can update, we can delete. You can Google all these queries if you want. They can get really complicated really quickly. So don't worry about that. So, oh my gosh, I spoiled it. I was going to throw some candy for that. Anyways, so what if I wanted to ask some more complicated questions, right? What if I wanted to get the username of a post? Well, you notice, pretend that the bottom half of the slide doesn't exist. You notice I can't really do that, right? I have my users with usernames. I have my posts that don't really have usernames. And so one thing you might say to do is, okay, I'll grab this post, extract the username out of it, and then make another query that says, okay, find me the username corresponding to 2. And that's how you would think about doing it. But another benefit of SQL-based databases is that it gives us a built-in way to do it. Because basically, with this magic word called join, we can slap these two tables together and just write out what we want to do, and the database will do it for us. And with this, we get the benefit of someone who has spent years of their life optimizing for this situation. And so it comes back really quickly. It's a lot faster than if you did this by hand. Right. Any questions? Cool. So that's SQL in a nutshell. And the good news about all of this is you're like, oh my god, I have to learn another programming language. If you use a framework like Rails, it'll basically do all these things for you. The only reason I showed you a little bit of SQL is A, it's pretty much still the most common database used out there, so it's good to have a basic understanding of what's going on. And B, if you're ever debugging your Rails queries and data looks like it's not coming out the way it should be, maybe you can look at some of those queries and figure out what's going on. Cool. So any questions about SQL structured databases? I'll give you an entire pack if you ask me a question. Not confused, that's also good. Cool. So, in contrast to SQL, we have NoSQL, not SQL. Not only SQL, just not SQL. You might have heard of MongoDB. It's the new sort of hipster database that every startup uses, in addition to the node and the sockets and everything else. And the big data in the cloud, of course. And instead of tables inside databases, it's really the same concept, except now we're going to call them documents inside of collections. So if you're ever reading the Mongo documentation, you're like, what's a document and what's a collection? It's really the same thing, sort of. The idea is you have these documents, which are individual entries in a database, and you put them inside collections of documents. And NoSQL is almost always used with JavaScript frameworks because it's really easy to go in between the database and your JavaScript framework. If you have an object in JavaScript, you can literally pass that object into the database, and the database will handle, like the whole storing of what a JavaScript object is. Whereas, for example, in Rails, Rails has built a giant engine in between the Ruby stuff, the classes in Ruby, and the SQL data that gets stored on the database. And you don't have to worry about that if you're using Rails, but there's a giant engine somewhere out there that someone has built. Whereas in JavaScript, we're basically passing these JavaScript objects around, and everything just works out. Right, so JavaScript objects. Remember, JavaScript objects can take basically anything. Keys can be basically anything, and their values can also be basically anything, including other objects. And you might have heard of this thing called JSON. I didn't really talk about it too much until Bloomberg came in and just started talking about JSON all day yesterday. So this is JSON. JSON is really just the same thing as a JavaScript object, except it's in a string form. So since the internet doesn't have any concept of what an object is and what these different data types are, what we do is before we send things across the wire, we change everything into a string. So the internet only has to deal with basically sequences of characters. And that's how the internet is. Communication across the internet is built. And you'll notice, if you ever use the browser function like json.parse and json.stringify, you'll notice that if you pass in a JavaScript object, it basically looks like the exact same thing. You just have a couple more quotes and make some things strings, and then you're set. And the nice thing about MongoDB is that we can take these JavaScript objects right here and just pass them straight into the database. So I have a database called users, and I'm just going to insert this JavaScript object. And Mongo will handle taking care of how exactly it's going to store this, but we don't have to worry about it. Right? It's almost exactly like back on slide 1, where I showed you that fake database that I had created in my application. I can just take this object and insert it. And Mongo will magically deal with that. You'll notice here, between this query and this query, that a lot of things changed. Right? Name and age here, string and integer. Name and course, string and string. This would not fly in SQL link. It's just it would break in unimaginable ways. But in Mongo land, we can do all these things. And we can find things. We can go to post and find for author Charles, or maybe author ID 1, and Mongo will give us back a JavaScript object. We'll talk about this a little bit more on Tuesday. But whenever you're dealing with a Mongo database, you're passing it in JavaScript object, and you're taking that JavaScript. And that's beautiful. It's fantastic. That's why I love JavaScript frameworks. But these two lines here show us a very interesting problem, which is actually it shows us a lot of problems. I really want to throw some things at people. So what are some problems that we might encounter if we're using a database like this? Yeah.
People might put in data types that you don't want.
People might put data types that you don't want. Ooh. We're going to get 3 more things that are wrong. 1.
You can't rely on every document having the same information. Like, so one person has the age and the other person has the course.
Right.
Consistency.
You see that, okay. Right, so if I do a db.users.find, and I either pass in Charles or Victor, I'm going to get an object that's completely different. And how's the rest of my code going to even handle that, right? Like, I might say, okay, well, Victor has a course, so I might, take some input from a user and say, whose information do you want to look up? And they'll be like Charles. And so I'll get this record and I'll say, return to the browser Charles user result dot course. And JavaScript will be like, I don't know what that is, and then return undefined and not throw an error, and we will never figure out what's going on. Any other problems? Yeah.
Fields aren't enforced, so the database can't index on anything. It makes things slow when you scale up.
You're mostly correct. Mongo does have a lot of older optimizations built in, which there are different queries for doing that, and Mongo can enforce some things, but you don't. It's true. You don't have the built-in structure that you would have in a SQL database. Yeah, last one.
Mongo isn't fully ASCII compliant at the transaction level, so you
Woo! Big words. Mongo is not fully ASCII compliant. Don't worry. This definitely deserves. But don't worry about what it means for Mongo to not be fully ASCII compliant at the transaction level if you don't know what those words mean. In a nutshell, what it means is, unless we are very careful with the way that we structure our queries, that two-step operation that we did, like me deducting 50 from my account and then giving 15 to Victor, we're going to have to be very careful how we actually do that. Otherwise, we might get weird behavior if, say, the server goes down in the middle of it. That's impressive. All right. So, but the biggest thing is if you're just using MongoDB by itself, when you pull a record out of the database, you don't really have a guarantee on what it is. You just have some object. In Mongo, they don't care what things you have in it. In JavaScript, they don't care what things you have in it. Life can be really disappointing. And a shameless plug for my lecture on Tuesday, I'm going to resolve all these problems with a JavaScript framework. In addition, I'm also going to show you how to build these really simple relations, like the ones that we had in SQL with the foreign keys in MongoDB. And everything will once again be magic after my lecture on Tuesday. But hopefully, any questions so far? I should save one for questions. Save one of those candies. But any questions so far? All right. So yeah, not too much code yet. Just by a show of hands, how many people have started building their app? Cool. How many people know what idea, have chosen an idea out of their 10? It's going to be a fun Friday night. Alright, so, I don't feel too bad for not showing any code details yet, which is good. So yeah, on Tuesday I will go back into building a Node application and show you guys how to really integrate these Mongo queries inside of a database. And so, as promised, this is just an introduction, a quick primer to databases. I'd like to welcome Firebase. Is Firebase here?
Over here.
Oh, okay. Yeah, I'd like to welcome Firebase. I'm not going to talk too much about what they do, other than just take one quote from their site. A powerful API to store and sync data in real time. Ooh, man. So yeah, welcome, Firebase.